Well, hello friends. Today we are going to work on the browser a little bit again. But it's going to be a bit of integration work, because if you open this Happy Birthday Serenity OS page here, I have a local copy of it, and it has a bunch of images on it, right? And if we look here in the system monitor and we sort by physical memory used, we'll see that the browser process here is using up a lot of physical memory when we have this page loaded. Almost 32 megabytes, which is clearly a ton, right? For a browser these days, oof. Most of that is going to be images, though. If we sort here by resident, we can see that the biggest allocations by far are all of these graphics bitmaps. And we see that they are all about the same size, because these are all my, my screenshot thumbnails, and they're all about the same size here. And actually, until you've scrolled them into view once, they actually don't show up, because we decode the PNGs lazily. So they only get decoded the first time you scroll them into view. So today, we're actually going to make the second part of that thing. So you scroll them into view, and they get decoded, which bloats up the memory. But today we're going to use the Purgeable memory feature to make sure that when you scroll them off screen, then we're not going to free the memory, but we're going to tell the kernel, if you need this more than I do, you can take it. So this will be a use of the Purgeable memory feature that we added a while ago. I think it's going to be really sweet. So basically, step one now is going to be making all these graphics bitmaps be purgeable, and then marking them as volatile or non-volatile depending on where they are in the viewport, and like relative to the scroll viewport of the page. And then finally, we're going to need to be a little smart in the web browser and know that if an image disappears, like if the decoded version of an image disappears while we are scrolling, or while we're up here, then some image below disappears, then we have to re-decode it, basically, if we scroll it back into view. So we want to go back to that earlier state. And hopefully the result of this will be that the sort of, it's not really the net memory usage, but like the effective memory usage, or whatever you want to call it, of the process will go down, because the kernel will have a way to recover most of the memory. So let's get cracking on this. So I guess the first place we got to look is HTML image element, because all of those things are image elements. And the way this currently works is that they all have an image decoder object, which is a libdraw thing. And it owns a plugin, and in that, I think it's a PNG image decoder plugin in this case, which has the PNG loading context, which has the bitmap. But I think in the case where we throw away the if you're going to throw away the bitmap, then the easiest thing is probably to keep the encoded version of the image around, but throw away the image decoder and just make a new one when it comes back into view. So I feel like that should be doable. Alternatively, if there would be a way to tell the image decoder, hey, throw away your data. I'm not really quite sure. It's a bit weird that the way that this is structured. The reason that we keep the image decoder is because there's a two-step decoding that happens at the moment. Like, the first step is we only decode enough of the image file to get the geometry, so we learn how big it is, because we only need the width and the height of an image to figure out the page layout. And then we can actually defer decoding the image pixels until we want to show them on screen. So that's what I was talking about, how we don't actually decode until we we see pixels. But all right, so that's why we keep the image decoder around. But let's look at making these purgeable to begin with. So we want to make sure that we are giving out purgeable bitmaps from the image decoder. So when you're asking for a bitmap, where do we give you a bitmap to begin with? We have PNG loader, graphics bitmap create. Okay, so we have this guy right here. I think we're gonna make a new helper. That will be, it's just a format and a size. Yeah, right. So we'll have this one, create purgeable. And I think we'll have a purgeable tag or something like that. We want it to take a different constructor, so we'll just have a purgeable tag. Purgeable tag, purgeable. All right. Now how's this going to work? Purgeable tag. Ignore. And then we still need m on map. We want to map this with purgeable instead of anonymous. And I guess other than that, we don't really need to say too much. This is actually, maybe I'm overcomplicating this. I didn't need that separate constructor. We can just have a flag. Purgeable. Yes. Enum class. No. Yes. Just do it this way. Purgeable, no. Okay. Now we'll say int map flags. Purgeable is purgeable, no. Or we'll do yes first. Map anonymous, map purgeable, map private. Otherwise, map anonymous, map private. All right. Map flags. We have done it. Hopefully, we have made a purgeable allocation. And purgeable. I think we'll do something like this, and then we'll store a Boolean right here, m purgeable false. And then we can have bool is purgeable const. And then we'll have no discard bool set volatile false. Or wait, what API do we normally have? We have set non-volatile. That's the one I care about. Okay. Because these APIs are going to be important to us, because that's how we're going to tell the kernel what's going on. feel like I have some kind of API like this already. Yeah, here. Shared buffer. So if advice, first we'll assert that we are purgeable. Data and size in bytes. Does advice always round up the size to a page multiple? Region from range. Yes, it rounds up to nearest page multiple. All right, so then, still compiling, Jesus. Okay, so we're just gonna advice the data, the size in bytes, and mad set non-volatile. I guess in this case we will pair advice mad set non-volatile. This is not supposed to happen, so we'll assert not reached. And oh, actually, we need to store this somewhere. So do something like that. Oh, finally. So if RC is 0, everything is good. The data is still there, so we return true. Otherwise, we return false. When you set volatile, we just have to mad set volatile. And can just return bool. And if RC less than 0. Not reached. And then do nothing. All right. Oh, damn it. Now I changed the header anyway. I was trying to... I thought I wasn't going to change the header. It would avoid the big recompile. Anyways, so assuming that we did everything right, then we should be able to call set volatile on bitmaps that we got from the PNG loader, basically. PNG loader, it uses create purgeable, and then these bitmaps are what it will give out. So we are now going to be responsible for that image being available. So where do we do that? We currently, so the way that we render images in LibHTML is we have this thing called layout image. And the layout image is a CSS replaced element that just ends up in the layout tree. And the way that we render it, you can see here, if it's not visible, then we don't render it. This should probably be done at a different level. And here comes a comment that says exactly that about something else. This should also be done at a different level, but ignoring that, if it doesn't render as alt text, and we do have a bitmap, then if we do have a bitmap, then we draw it scaled. So I think here is the magic. Here is where we need to how is this going to work? I think we're going to need to have a concept of, like, if you're asking for the bitmap, we need to make the bitmap happen for you. Because if you're doing this, then that means that we're painting, and then we need to plumb the currently visible viewport needs to be plumbed from wherever we track it down to the layout tree, and then we need to, whenever the viewport changes, we have to go through the layout tree and find any images that are outside of the viewport, and then, or we have to find all images and then just mark them as volatile or non-volatile depending on where they currently are in relation to the viewport. So how do we know where that is? The HTML view is the high-level widget that scrolls. And do we have a real event? Scroll. It just has a vertical scroll bar value, so we don't actually know that it has scrolled. We just get told to paint. So maybe we should have a scroll event of some kind that just lets you know that scroll happened. And I'm kind of thinking, like, how should it work? I guess scrollable widget. So we could either have a scroll event, or we could also have some, I mean, the events sort of happen at the G widget layer, but I'm thinking we could have something more like a protected virtual that gets called on G scrollable widget when it scrolls. So how does this happen? Scroll into view, and then what actually happens is that we just set the scroll bar values. And then we have onChange, where we call did scroll. Aha! So did scroll. That's the event that I wanted, basically. So I just need to hook did scroll. HTML view. Okay, this was going to be easier than I expected. Void did scroll. Oh, let's say virtual. Okay, now when we scroll the HTML view, let's scroll, then we have the visible content rect. This is the G-scrollable widget's idea of which rectangle in content coordinates is currently visible. So this is exactly what we want to, anything that's intersecting with this, we want to keep it in memory, keep it locked down. And anything that's not intersecting with this, we can kick it out of, we can make it volatile, basically. So let's call it the visible, or the viewport rect, maybe, something like that. Okay, and then we want to iterate through everything. So how the heck do we do that? Document. We have the layout node. What is that? It's layout document. Okay, so we know that we can start from there. I guess we'll do something like this. Start document, or actually, if no document, return. If no document, layout node, return. All right, and then we'll say layout root is document layout node. But this feels like this is very hackish. We shouldn't be doing the logic at this layer. Now that I think about it, we should instead just push this down. So we'll push this down to the mainframe, say. Mainframe set visible set viewport rect. Okay, this will be better. And then the frame will know. So void set viewport rect. And we can also allow you to fetch it. Viewport rect. All right. did scroll. Thinking maybe we need to keep this in more than one place, or set viewport rect. Maybe this, where else do we need to do this? Maybe in resize event. Let's do that there too. Like that. We'll do it there. It's a little bit unclear to me if the viewport rect should include the scroll bars. Maybe it shouldn't actually. Set content size. Mainframe set size. Oh, that's sort of where we do this now. Set the viewport rect. Okay, so when we're scrolling, really what we're doing is we're setting. We were already tracking the size of the viewport. Actually, we just now we're going to also track the X and Y offset of the viewport. So where am I looking at? This isn't what I want to see. I want to see this layout and sync size. Right, so mainframe set size, available size. What's available size? That's how much space we have. Okay. And visible content rect is what exactly? I feel like that's what we should be showing. Set viewport rect, visible content rect, then set size. Because this takes scroll bars into account. Yeah, right. Okay, frame. I'm gonna figure this out. So we'll make this just return the viewport rect size. And that actually returns, oh, we have to do it this way. Okay, we'll just do it this way for now. Okay, does this compile? See if we're on the right track here. Frame set size. We'll trade you for set viewport rect. See apps, browser, and sync and run. Okay, viewport rect is missing. Seems totally avoidable by just returning the viewport rect. But who am I to be difficult? Okay, so this did not work out the way I wanted it to. It seems like we're ending up with a pretty small viewport rect here, so we should maybe log set viewport rect to see what we're actually setting it to. 0 by 428, right? So we're not getting the right width, only the right height. And the visible content rect has the wrong width. And that's because the width is driven by the content, which we, shit. Okay, so this can't be working like this. The viewport rect. Okay, So I had the wrong idea here. We have to keep feeding it the available size because that's how much space he knows is available to him. And then the viewport rect is just something on top of that. Fine. Then line set size. We'll keep this the way that it was. M size. Oh. Let's just fix this up real quick. Viewport rect size. Oof. Right. No, not rect. Size, size, and size. Okay. So we can see the viewport rect over here. It looks somewhat sane, right? We should change it when we resize though, because then it definitely changes. So in layout and sync size, we need to update the viewport rect right here. Frame set viewport rect, visible content rect. There we go. Scroll a little bit, resize. Yeah, we can see that it's updating in a sensible way. Good. Now we got to react to this. So here in frame set viewport rect, this is where we're going to have to do some magic, I guess. So let's just put the logic. Where do we want to put the logic? We can put it here, I guess. Or can also move it down to the layout tree, which would be nicer. So we'll say if m document, then and m document layout node. Layout node. We'll include that from here. LibHTML layout node. Did set viewport rect. Oh shit, got the wrong type. Okay, now in layout document, let's have a function for this. So this will come from frame every time, so we'll make a badge for it. Just to make sure that nobody else calls it. All right, poop. Now, how are we going to handle this? Did set viewport rect. Wow, that's so large. Just ignoring this warning up here, by the way. So I guess we can just walk the tree for each and subtree. Wait, how does this normally work? You call for each and subtree, and this just iterates your whole tree. Okay, so now we can do something like if, how do we recognize a layout image? We have, oh, we need some way to recognize it. So we're going to have a ritual bool is image const override return true. And then I think in layout node we'll just have some way to recognize that. Okay. Oh, and we need to add one of these guys. So we can is. Okay. Now we'll be able to check for each subtree if is layout image layout node. If it's not, then return iteration decision continue. Maybe we should write it this way instead. It's a bit tidier. Okay, so if it's an image, we'll have to look at the box and see if it intersects the viewport rect. So image hold on, is to layout image layout node. How do we get that? Layout image is a layout replaced, which has layout box properties, so it has X, Y, width, and height. But does it have a rect, actually? Yes, it has a float rect. So we can just query the rect. Of course, the rect that we get is an integer rect, so we're going to have to turn it into a float rect. It's a bit annoying. I can just convert it like this, maybe. A viewport rect. A viewport rect height. Okay, there we go. And if the image dot rect dot, or let's write it this way, if viewport rect intersects if they do, then image set intersects viewport. Maybe we can do it this way. Set intersects viewport that. Okay, and then in layout image, set intersects. I mean, this is kind of this is putting too much information into the image. We'll just say like set image non set should keep image, should retain image. Maybe just set volatile. Okay, we'll do it this way. Set volatile pool. Okay, now. Oh, by the way, I forgot to check if the images were. We got all these images, right? And did they actually become purgeable? Order by size, and all these big images here. Of course, we have to scroll through the whole document to get all of them. And yeah, they're all purgeable, but they're all non-volatile, which means that if we were to tell the kernel to purge, it would purge a lot of stuff, but it would not purge those particular bitmaps. Although, why is it purging so damn much? That's weird. Purgeable purge. Guess we're probably purging a bunch of shit in the system monitor. And over here too, probably. If he's minimized, then there's nothing to purge, because he doesn't paint. Oh. Okay. Yeah, it's that blinky thing, probably. We're probably painting even though the blinking thing is not visible. Anyways, lots of things that can be better. So when it comes to this though, we want to get all of those big ass bitmaps to be volatile, because only this one is on screen. And we want to be able to purge and get this guy down to, you know, whatever it is when the page is fresh, like 10 megs, right? Purge should get us down to 10 megs physical. That's the goal. Okay. So, we'll have layout image set volatile, and this, I guess we'll just forward the state to the image. If node bitmap, but this thing will lazily create the bitmap, or no? It's only if it has a decoder. Okay, okay. So I think we'll pass this on here to the DOM node. Set volatile B. HTML image element. Or there's this weird interaction between the layout tree and the DOM tree here. Yeah, let's put it here, but let's use a badge. Badge. Set volatile. Oh no, cool. And this can use a badge layout document. I'm not sure that this architecture is very good. I'm starting to feel like it's a bit suspicious, but we'll just soldier on. Document, that's the one I wanted. Okay. Oh, this is well, we'll just const cast it to get out of the way. Okay. Too few arguments. We'll make a batch. There we go. All right. So now we are in HTML image element, and we get a set volatile call. And if we don't have a decoder, we can just, oh no, actually what we want to do is if m bit, do we store that anywhere? M bitmap. We never store it. Oh shit, okay, so the decoder keeps the bitmap. So this here is just some artifact of some idea I had, I guess. So this is what the layout looks like. We have the encoded data and then the image decoder, and then the image decoder internally has a bitmap. So maybe this is all about pushing the data to the decoder. Should the decoder manage this? I'm not sure. If there's no decoder, then there's no bitmap. Otherwise, here we'll say bitmap set volatile if v else turn volatile is easy, because then you're just telling the kernel it's okay to remove this if you feel like it. Non-volatile, this is the tricky part. So was purged. This is the important thing. So when we set this to be non-volatile now, it will return true, or rather, kept data. Or what the hell do we call it? Pixels. I have some name for this that I use somewhere. Pixels. Where the heck did I use this? I already forgot. Maybe I never did. Ugh. Kept data. Okay, because when we do the mAdvice, we return 1 if it was purged and 0 if it was not purged. But then we flip that around so that the API returns true if the data stayed alive. Kept decoded image data. If we kept it, return. That's good. Otherwise, we have to redecode. And I think if that happens, we can, we'll just lazily create the bitmap, right? Yes. Okay, so I think if this happens, we can make a new decoder. Decoder equal, yeah. So this is a bit weird, but we'll do it this way. Because we could also, you could imagine calling like reset on the decoder, but this seems easier to just recreate it. Of course, I have no idea if this is actually going to work. Probably, we're missing a little bit of business. Set volatile. Pass a badge, and then I think we're gonna have to make volatile a. It's gonna need to remember if it's already volatile and then ignore it, basically. So, set volatile. Or what happens if you call set non-volatile when it's already non-volatile? Then we should just return that you kept the data, right? So this mAdvice, what will happen in practice? We'll set volatile false, and then was purged is going to be false. So maybe it's actually okay. It will just tell you again, they're like, dude, I didn't steal your pages. I didn't purge. All right, so load all the things. And then what if we actually purge then? I feel like we're gonna crash. Okay, so we purged a shit ton. We got our physical down to 8 megabytes. Holy moly. But what if we start scrolling though? Oh, the images are all gone. Dang it. All right. So we're still working on it. See, now it's so big, 32 megs. That's an epic purge though. Now it didn't get quite as small, but we can purge down to 12 megs. And if we scroll, oh, we had 2 on screen, that's why. Scroll them off. What happens if we try to purge the rest? Ploop. Purge a little more. Well, we are not reconstituting these correctly, so that's not good. Set volatile. So let's log that this is happening, maybe. Set volatile. This feels really weird to do this in the DOM element. We could do this in the layout node. might be a bit nicer. Layout, no image, rather. And then we'll just have the image element exposed to its decoder, which it already does. So I didn't need to do this, but I need a way to kill the decoder actually. So, maybe I'm just grossed out by this indirection here, but let's live with the indirection. But why does it not work? Set volatile. So when we call bitmap, it creates a bitmap and then makes it volatile. So it will always create it in this case. So that's not very good. We should probably have a way to ask for a bitmap if there is one. But maybe image decoder should just have a way to directly affect the bitmap volatility. So we'll do that. Void set volatile. And we'll make this, or yeah. Set volatile. Cool. Set non-volatile. Card. Okay, and then we will make these two. Okay, and then in the PNG image decoder plugin, we will just add these. Okay. And how are these going to work? These are just going to be PNG image decoder plugin set volatile. If m context, do I even have a context? I guess I always do. So if I have a bitmap, set volatile. Set non-volatile. If I don't have one, return I don't have pixels, and otherwise return set non-volatile. Okay, so this will return whether or not you have a bitmap, basically, and the bitmap is still intact. Very strange API, but I feel like maybe we need to recompile some stuff here actually. So HTML image element. So we're doing the wrong thing now. We need to set volatile directly, and here we need to set non-volatile directly. Otherwise, we're creating bitmaps. This still has image. Okay. Okay, and then hit me with a purge. All right, we took him down quite far, and oh, we got some bitmaps, but we don't get all of them back. That's a bit weird. So maybe the logic is just not right. Let's see. Image element. I guess we're interested in when we're being told that we are in the viewport. So we'll say something like debug if v in viewport, and we can say our source, else debug outside viewport source. All right, then we'll do something like that. This will be interesting. Because now just scrolling should tell us, okay, so he thinks that everyone's in the frickin' viewport. Okay, so he's a stupid idiot. That's the problem. Or no, wait, hold on. Volatile means outside the viewport. Okay, I'm stupid. I'm the idiot. Okay. At least we were able to determine that quickly. Okay, so most of them are outside the viewport, except we got these two guys right here. 0110, 0110, and 019, presumably this image. So this seems, you know, pretty correct just based on a cursory glance, right? We'll scroll 0121 into view, and we see 0121. Right here is in the viewport, which means that we will be calling set non-volatile on him. So set non-volatile. Maybe the PNG image decoder. Wait, hold on. Let's go to sysmmap and fix this up a little bit. So mad set non-volatile. If you're setting non-volatile on something that's already non-volatile, we'll just return 0. And we don't touch anything else. I think that does feel more sane. Well, I'm not sure that fixes the issue, but because I guess well, actually maybe it does fix the issue, because when we set non-volatile, then we clear the was purged flag. But if you keep calling set non-volatile over and over, then we will forget that we purged. But this way, we ignore multiple calls. But does that actually change anything? I feel like I'm just missing the fact that it's flipping. Purge. Yeah. It's weird how some of them very bizarre. So maybe we need to track this somewhere. Maybe we need an API to query if something is volatile. So that would be, maybe that's the easiest thing to do. We can just do that, like define mad get volatile. Let's do that. Get volatile. Maybe mAdvice is not the best for this also, but it's a bit weird. Anyways, so we'll do if advice and mAdvice get volatile, and we'll do return is volatile 0, otherwise 1. Okay. Now we'll be able to use this somewhere. The graphics bitmap. We set volatile. We should probably manage the state ourselves, actually. So we'll say m volatile false. We'll start out in false, and then if m volatile check true. And we don't even need the change to the kernel. Oh. Oh, and we have to actually update the flag. Jeez. True. And then we can also add this as a getter. Okay. Now where can we make use of this? PNG loader. Oh, it doesn't matter. So what is the problem? Problem is, it feels like to me that the problem is that we don't get here. Because we think it already has the image. And we think it has the image set non-volatile. We think it has the image if we get true from this guy. So set non-volatile. We get true back because it was not volatile to begin with, or because we get a 0 from mAdvice, which means that it was not volatile in the kernel, or it was not purged. Okay. So I feel like I'm doing it right, but clearly maybe I'm not. Okay, so let's see here. Debug. Remake new image decoder for src. This one will help us. Make. One of these days, I'm going to get a better computer. One of these days. I'm just waiting for everything else to clear up first. But if there are no unexpected gigantic expenses, then computer seems like a good investment. but we'll see. All right, just let me at him. Purge. Oh, damn it, I messed it up. Gotta scroll everything into view and then purge. And they're gone again. Why are they gone? Oh, frick, I forgot to look for that message. Okay, so let's reload the page. Okay. So now we have all of these guys. And what was that scrolling by there anyway? Make new image decoder. Okay, that's a little bit weird. I've never purged. Suspicious. Or maybe this happens the first time we call them. Okay, so I think we're good. Now we get a purge, and then we scrolled some guys in, but we don't make any new image decoders. Don't make any new image decoders. Well, why not? So we're clearly setting them, we're in viewport. And maybe we should say an image decoder. But if we do have an image decoder, we should be going here. Let's say like has image. Alright, blah, 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 blah. Purge and scroll. So these two guys are in the viewport. They have a decoder and they have an image. They think, but they clearly don't. So why do you think you have an image? Well, we call set non-volatile on the image decoder, which returns plugin set non-volatile. So has image is true, so we didn't take this branch. We must have called set non-volatile on the bitmap, which would return true. Set non-volatile. So if mVolatile was already true, or already false rather, then we'll return true. Otherwise, we will madvise set non-volatile. So we're gonna have to trace this a bit more, I guess. Set graphics bitmap set non-volatile and volatile. What am I trying to do? Was like this. Okay, and debug. Advise returned RC. Draw. I'm going to figure this out. Poof. So this guy had no image. We make one. It's fine. Okay, now I just messed everything up. I'm gonna try again. So now volatile was true. Okay, so it was volatile. madvise returned 0. So, mAdvice, you jackass. Why are you returning 0 for this particular image? Is it because we are here? Debug sys mAdvice returning 0 for already non-volatile. Was purged 1, 0 due to purge flag. Okay. So, turning 1 due to purge flag. mAdvice returns 0. Wait, what? What's going on here? mAdvice returning 1 due to purge flag, and it says return 0. Why is that happening? We'll do this just to be super safe. So we print the same thing in both cases. But what the actual frick? So it seems like we're returning one value and ending up with a different value in user space. Why? But let's just verify that that's actually going on. Okay, so we got all of the bitmaps. Hopefully, purge that junk, and boom. Okay, so mAdvice in the kernel thinks he's returning 1, but did I just mess this up? RC. Oh shit. What the heck is that? Who put that there? Okay, that was really stupid. Oh. Alright. Now that we don't compare with that anymore, maybe we can actually purge and then it's still not going to work, right? Wait. Oh shit, I forgot to rebuild libdraw. Because this has to be the bug. This is too stupid. Like, it's too stupid not to be the bug. Alright, come here, you. I'm doing this. Okay, now, come back to me. Ooh, boom, bam. Look at those images just getting loaded automatically again, finally. So, this now means that the browser process can bloat himself up. When we browse this page, he can bloat himself up all he wants. All the way up to 32K, 30 meg rather. But then if the kernel says, bruh, I need some of that memory for my stuff, then it just zaps him down to 8 megs. This is so awesome. We can see all of the images down here actually. So if we scroll a little bit, we just scroll somewhere random, we see now one of these images pops into place. Maybe we can do some other stuff. So if we scroll, we'll see here that more and more of these images get decoded, so they come into resident memory. But as we scroll, we see that only the images that are in the viewport are non-volatile. Everything else is volatile. So if we purge, for instance, when we have these two guys on screen, then, or in the viewport rather, then we should be able to see all of the volatile ones have their resident memory go down to 0, and the non-volatile ones, this guy here and this guy here, they should stay resident. Oof. That's so neat. Okay, how neat is that? Of course, this isn't even the final form of neatness, because right now we have to like force a purge to happen. The idea going forward is that the kernel will be able to purge selectively and at a time that the kernel likes, you know, and can choose to purge in inactive processes and all kinds of criteria. Right now we just have this one big purge all just for testing the mechanism, but this is going to be a very, very good building block for a very, very good memory system, I think. So, volatile, let's purge it. It's volatile, but it stays resident. That's interesting. This one is non-volatile, it's resident. Something is a bit weird there. Why does this thing not go away when I purge? Or does it? Oh, wait, hold on, the address changes. So BR. I'm not exactly sure why the address changes when I purge it. I mean, I was just thinking, like, is the browser painting? But why? It's doing syscalls. What the heck is the browser doing now? This has made me curious. So let's profile it, since we're here. It's clearly it's doing something, so what are you doing? You absolute goofball. It's doing a little bit of paint. Just the tiniest paint, but why? Well, I don't know why that's going on, and I'm not going to investigate it right now. Maybe it's the blinking timer for blinking this cursor or something. Very, very weird. But it's clearly waking up. All right, anyway, whatever. Let's turn this into some commits. Crap, we have many changes here, so let's look at what we did in the kernel. So I think in the kernel we can clean up some of the messages, and that get volatile, we don't actually need that. Well, we can also keep it because it doesn't hurt to expose that information. So I think we'll do that. We'll do this guy, and man. And let's see, get volatile. Kernel. I'll add memad get volatile for checking if a volatile flag. Sometimes you might want to know if a purgeable region is volatile. Then we'll also add this. Kernel. Ignore mad set non-volatile if already non-volatile. Just return 0 right away without changing any region flags. Okay, and then we had some changes in graphics bitmap. So we're making it possible to add a purgeable, create a purgeable bitmap. And I was adding all this debug nonsense because I was paranoid. And eventually it was because I made this dumb mistake. Silly Andreas. Jeez. So this is just graphics bitmap purgeable. Withdraw. And graphics bitmap create purgeable. This allows you to create a process private purgeable graphics bitmap. The volatile flag is controlled via set volatile, set non-volatile. Okay, and then an image decoder. We're making it possible to set the volatile flag on the decoder, which, okay, so we'll say withdraw. Create a purgeable graphics map in the PNG decoder. Also add image decoder APIs for controlling the volatile flag. Okay, and then HTML view and frame, or wait, no, hold on. Is any of this standalone? There's a lot of noise here. In viewport. Okay. Load. Okay, so I see one change we can do separately. So let's say git add layout node h and image h. So it's just adding the isImage helper. Node HTML add layout node is image and is layout image help. Okay, and then we'll put that back. And then we want we're pushing the viewport rect from HTML view down to the layout tree. So let's do that in a separate commit. So LibHTML h frame I think in the frame we can omit this part at first. Oops. And we have this nice standalone commit, and we can also fix this because minimize the diff. It was there before. Okay, so now we're just pushing down the visible content rect into the main frame, where it will be known as the viewport rect. Oh, wait, hold on. Frame CBP, I had this as well. LibHTML, push the visible viewport rect from HTML view to frame. This will allow frame, or this will allow various mechanisms and optimizations based on the currently visible viewport rect. Yeah. Okay, and then we put that back. And I didn't really love the way that this code ended up, because layout image was just forwarding the call to the DOM element, which is a bit gross. So I think we can just put the grossness here. Wait, layout, no, no, that's the wrong place. But we can put the grossness here, so we can do like image node like that. And then we don't need volatile in layout image. But in HTML image element, this call is going to come from the layout document instead, but maybe that's okay. So we'll just have him take a batch for that. We'll update this. Okay. And so this is what we end up with, right? So the frame tells the layout document, which is always the root layout node, tells him the viewport rect was set to this, and then we have to make a float rect out of that because it's integers. And then we walk the whole document subtree, which is the whole document, and for every layout image that we encounter, we say set volatile. It's called set volatile on the node, which will be the HTML image element always. We tell him you're volatile if your image rect does not intersect with the viewport rect. It's pretty good. It's pretty good. And this is a little awkward, but I think it's okay. So we'll say HTML. Mark images outside the visible viewport volatile. Mark image bitmaps So hat frame when the visible viewport rect changes, we walk the layout tree and check and then check each image, layout image. Check each layout image. Check where each layout image is in relation to the viewport rect. Images outside have their bitmaps marked as volatile. This is the images. Note that the image bitmaps are managed by image decoder objects, not by the layout image or the HTML. Oh no, layout. If a bitmap is purged by the kernel while volatile, we construct a new image coder next time we need pixels for bitmap. Pixels for the image. Yeah. So that's pretty cool. Now, there's one thing that I was thinking about. What the hell was it? In layout document, for each in subtree, wouldn't it be nice if you could do this for each subtree of type? You could just do that. That would be really neat. Can we do that? Tree node. For each in subtree, can we make a of type version of this? We'll just have it like a type name T. Oh no, not T. U, because T is the node that we are in. So U is the type we're looking for. So let's see, how would this work? If this, oh wait, we gotta check if it's a U. So if is U, static cast T amp this. Would this work? Oof. We would need to have a prototype for is. So what if we knew that there was a template? Type name X is cost T. Can I forward declare like that? Would you let me do this? Bool is, It's a little bit weird, but would you let me get away with this? And here we would look at the child. compiles. But, oh no, it doesn't. Okay, wait, hold on. For each subtree of type. Could introduce template parameter u. Really? Why not? I need to put that first. Right. Okay, I'm too tired for this template bullshit right now. I'm just gonna call it a day. I don't want to deal with you right now, template man. So I think we made some good progress here anyway. And this is really cool. So I'm very happy with it. And actually, why is it so spammy? I definitely removed all that gunk. Okay, so we have some missing things. Layout document. Good thing I didn't push, because I guess I was editing a little too much. Const cast, HTML image element. Alright, so. Oh, that's still very noisy. I don't want that. Set non-volatile. Where did I even put those? Oh, wait. That's in LibDraw. I'm gonna just have to rebuild it. Okay, well, aside from that little template thing there, that I'm gonna come back for it at some point. Just I'm too tired. But aside from that, this is some pretty neat progress. So this will definitely help us going forward, making this kind of awesome stuff. And we should probably start thinking about having a effective number or something like that. Because if you have volatile pages, then we should probably treat you with a little more leniency, I guess. I guess is what I'm getting at. But I'm not sure yet. We'll see. Purge that shit. Look at him. He's all smaller. Oops, everything just comes back in. So cool. Okay, so I think that's going to be it for today's video. If you made it this far, then I thank you for watching, for hanging out with me while I struggle to use my own APIs and eventually prevail. I hope you saw something interesting here, and I guess I will see you next time. Bye.